Volume and surface area of a prism. So the volume of a solid is the amount of space that's inside the prism, or inside that 3D object, and it's measured in our cubic units. So again, we've got our little conversion chart. So it's the same thing. The only difference here is that we've got cubes, because that's what we measure our volume in, and therefore those numbers at the top and the bottom, so it's still 1,110, it's just this time it's times by 1,000 cubed, so 1 billion. Or here we've got 100 cubed, so we end up with 1,000,000. So just keep that in mind when you're doing that. So with our conversions, we're going 26 meters cubed, and I'm turning it into centimeters cubed. So I need to times it by 100 cubed. So that's going to give us that very large number there. For this one here, we have 6200 millimeters cubed. Going millimeters to centimeters, so I'm dividing by 10 cubed, which is going to give us, I move that decimal point 3 places. We go 1, 2, 3, so 6.2 centimeters cubed. So again, just follow that flow chart where necessary. When we look at volume and capacity, so these two kind of go hand in hand. The volume inside the shape can then be measured if you put liquid in it, which is our capacity. So really important key points here, that we know 1 centimeter cubed is the same as 1 milliliter. So if you think of those little cubes from primary school, those little centicubes, one of those holds 1 milliliter of water if it was hollow. We then have 1 meter cubed. So if you think a meter ruler and we make a cube out of it, it holds 1 kiloliter of water, which is the same as 1,000 litres. And then the M here, the capital M, this is what we call a megaliter. So this is a megaliter, and K is our kiloliter. So 1 megaliter is 1,000 kiloliters. So again, really important conversions there that we need to use. So here we're going 22 litres into centimetres cubed. So if we have litres, I need to convert that into millilitres to get it into centimetres cubed. So we know that in 1 litre there are 1,000 millilitres. So if we times this by 1,000, that's going to give us 22,000 millilitres. And if I have 22,000 millilitres, that is the same as 22,000 centimetres cubed, because they are the same. It's a 1-to-1 ratio. For B, I have 19,560 centimetres cubed, and I need to convert it into litres. So if we convert that into millilitres, because we know centimetres cubed are the same as millilitres. So this is 19,560 millilitres. And then to turn millilitres into litres, I'm going to divide it by 1,000. So if I move my decimal back in 3 places, I get 19.56 litres. Last one here, I'm going 6,800 metres cubed, and I'm converting it into megalitres. So we know that 1 metre cubed is the same as 1 kilolitre, which is the same as 1,000 litres. So I need to look at this and think, well, 1 metre cubed is the same as 1 kilolitre, and I have 6,800 metres cubed, so that's the same as 6,800 kilolitres. So then if I've got that and turning that into our megalitres, we are going to divide it by 1,000. So it's going to give us 6.8 megalitres. So that's the volume and capacity in those conversions. So then putting that into practice when we look at the volume of a prism. So a prism is just a 3D object, and the volume of our prism here is V equals AH. V is the volume, A is the area of the base, and H is its perpendicular height, or its height. Sometimes that height can be called depth. Just know it's once you've found the area of that base or the front face, you then multiply it by how far back it goes. The surface area is adding all the areas of all the faces together to then get that answer. So for this prism below, we need to find the volume and the surface area. So if we think about the volume, this space here on this triangle, this would be what we call our front face or our base, because if we were to slice this triangular prism, I need to slice it so that every time I slice it, I get the exact same shape. So think about a loaf of bread. If I were to slice it acrossways like this, I'm going to get a different shape every time, or it's going to be a different length. Whereas if I cut this through, so think of it like a Toblerone, it's going to be the same the whole way through. This is an equilateral triangle, okay? I can't find the area of an equilateral triangle. I need to find the area of a right angled triangle so I can get this measurement here. So if I break this in two, that means that this is going to be 4 centimeters. And I know that this is 8 centimeters. I need to find this measurement here for my height. So I'm going to use Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared equals c squared. I have c squared. So I'm taking it, I'm finding my other side. So a squared is 8 squared minus 4 squared. And if we get that, we end up with 48. And then to remove the squared, I end up with root 48. Now, I'm going to leave it like this. I'm going to leave it as that exact value because I don't want to round anything just yet, because I don't want to impact my answer. So I know that the height of this triangle now is root 48. So if I find the area of that front face, I have a half times base times the height, which is a half times 8 times root 48. When I put that in, I am going to get a decimal again. What I can do with this then is to find the volume, whatever that is. My volume is area times the height. So if I put in that measurement or leave it in, and you can do this in one go here, but it's kind of showing the steps of what we need to do. We times it by how far back this actually goes. So this is going back with a height of 12. So that tells me if I put all of that in, get my answer, multiply it by 12, I end up with 332.55. But if I want to round that to the nearest whole number, I'm going to get 333 centimeters cubed. So being really mindful not to round your answer the whole way through. Now for surface area, I need to find the area of all of the faces. This one is a little bit nicer in the fact that this is an equilateral triangle, so it makes finding all the sides a little bit easier. So if I'm looking at this front face, I have two of them, the front and the back. So I've got a half, BH, and I have two of them. So half times my base is 8, my height is root 48, which we've found, and then we multiply it by 2. Again, we shouldn't be rounding these answers just yet. So we get our answer, then we find the area of our rectangles. Now again, because this is an equilateral triangle, that means that each of these three faces are the same. So we have the area of our rectangles, which is BH, and we have 3 of them. So our base is 8, our height is 12, and we times by 3, so I get 288 centimeters squared. Now what you could do is from this answer, because we need to find our total answer or total surface area, is we take our 288 and we add this onto it. Because if we then add it on, it will do it all in one go to make sure we don't get any issues with our rounding. So we get 343.425. If we round, we get 343 centimeters squared, and that is to our nearest whole number. So really mindful with our rounding to make sure we don't get any errors there.